synchronous circuit, the change in input signals can affect memory elements upon activation of clock signals. But in case of asynchronous sequential circuit, but in case of asynchronous sequential circuit, memory elements are either unclocked flip-flops or time delay elements. In asynchronous sequential circuit, change in input signal can affect memory elements at any instant of time. So the synchronous sequential circuit is easier to design, but in asynchronous sequential circuit more difficult to design. So basically the main difference between synchronous and asynchronous sequential circuit is that in synchronous sequential circuit, the timing of the circuit required, it means there is a clock, but in case of asynchronous sequential circuit there is no requirement of clock, it means the circuits are not timed. So basically the main difference between synchronous sequential circuits, it means asynchronous and synchronous sequential circuit, is on timing basis. So it is easier to design in synchronous sequential circuit, but asynchronous circuit more difficult to design. So there are some example of sequential circuits like latch, flip flop, registers, counter, and so on. So basically latch, flip flop, register, counter are the example of sequential circuit which we have to study in further classes. Now we will go for the latches. So our next topic is all about latches. So first thing is latch and flip flop. Both the particular, first of all, now we have new topic latch. So basically latch and flip flop, uh, the both are most important memory elements. So basically we can also say that the most important memory element is the latch or flip flop, which is made of an assembly of logic gates. Even though a logic gate by itself has no storage capability, several logic gates can be connected together to ways the permit information to be stored. So basically there are different types of arrangement for these particular latches and flip-flops. So basically latch is used for store single bit. So of latch each type of latch known more formally as a bistable multivibrator has two stable states. It can remain in either of the states indefinitely. Its state can be changed by applying the proper triggering signals. It is also called a binary or one-bit memory. So basically latches and flip-flops both are used for storing one bit or storing single bit, either 0 or 1. Now we will generally make a particular symbol of latches. So basically if I'll make a particular symbol or block diagram of a particular latch, so these are the inputs, and there are two outputs. First one is normal output and second one is inverted output. So there are, first one is input and second thing is output. So there are number of inputs depending on the different type of arrangements, and there are two outputs. First one is normal output and second one is the invert or complement of the normal output, which is depends. If normal output represented by q, then the inverted output represented by q bar or q dash. So this is the general symbol of particular latch. So now there are different types of latch. There are different types of latches, like SR latch, D latch. There are number of latches. So we will start with the SR latch. So there are number of latches. So we will start with our discussion with SR latch. SR latch where S represents set and R represent, where S represent set and R for reset. The particular S here assigned for set and R for reset. So that's why the particular latch is known as SR latch. The simplest type of, we can also say that the simplest type of flip-flop is also called an SR latch. So starting with the particular logic symbol, so there are some particular, to defining the SR latch, we have to follow some particular steps. The first step to defining a particular latch, SR latch, first of all, we will start with the particular logic symbol. The logic symbol of SR latch. So there are two inputs, S and R. So both are the inputs. So these are the inputs. So that's why there are these are represented by inward arrows like this, because there are two inputs, so there are two particular lines which have arrowhead which are inward direction. Both are the inputs. And now we will go for the output. Every latch have two outputs. First one is Q and second one is complemented version, that is Q bar. So both are the outputs. So the arrow towards outward direction. So basically both are the outputs. So that is the logic symbol of SR latch. Now we will go for the particular logic diagram, or we can say that circuit diagram. So second step of the particular S to defining a SR latch, we will draw a logic diagram, or we can say that the circuit diagram of SR latch. Here we can implement a particular, or we can design, or we can show a particular circuit of SR latch with the help of two gates, like or NOR gate, or with the help of NAND gate. Now here I am drawing the particular SR latch using NOR gate. So first of all, like there are two gates, we already discussed about all gates. Now here I am implementing, or I am drawing a particular SR latch with the help of NOR gate. So there are two NOR gates. First NOR gate have a input R, and second NOR gate have an input S, and the next two particular input of NOR gates connected to the output Q and Q bars. So so here in the particular diagram we can see that there are two inputs R and S, and two outputs Q and inverted output of Q, which is Q bar. And there are two gates. You can also show in the particular diagram, there is a gate G1 and another one is G2. So this is the particular arrangement for a SR latch. So where R input represents reset and S represent set. So basically now we will go for the third thing, which is most important, which is the particular